Chemotherapy refers to the use of cytotoxic drugs to destroy cancer cells. To understand how chemotherapy works, you should have a good understanding of the biology of both the normal and the cancer cell. Both normal and cancer cells go through approximately the same cycle as they divide. After the birth of a cell, it enters the G0 or gap 0 phase, where it may rest for an indefinite period, or it may go into the cell generation cycle, starting with the G1 or gap 1 phase. The cell can stay in the G1 phase for several hours to several days, depending on the type of cell it is. The main function in G1 is protein and RNA synthesis needed for special cell functions. After G1, the cell goes into the S phase, where DNA synthesis and chromosomal replication takes place. From there, the cell enters the G2 or gap 2 phase, where further protein and RNA synthesis occur. After G2, the cell moves into the M phase, or mitosis phase, for cell division. This is approximately 1/2 to 1 hour. Chemotherapy drugs act on cells that are actively dividing. Cells that are in G0 or gap 0, or the resting phase, are not as affected. Dead or dying cancer cells, which make up a portion of the tumor mass, also are not affected by the chemotherapy drugs. Chemotherapy is most effective in the early phases of tumor development, when the total number of cells is low, because the cells are still very actively dividing. When the tumor increases in size, fewer cells divide, making the tumor less responsive to chemotherapy drugs. Also, with increased tumor size, the patient generally becomes more debilitated and less able to tolerate treatment. Chemotherapy drugs are lethal to normal cells as well as cancer cells. However, normal cells are thought to be better able to repair themselves. Now we will discuss the cell kill theory. Chemotherapy is thought to kill a certain percentage of the total number of cancer cells present. For example, if a certain chemo drug had a 90% cell kill rate and the tumor in question had 1 million cells, the first treatment would kill 900,000 cells, leaving 100,000 remaining. The second treatment would also kill 90% of the cells, then leaving 10,000. After a number of treatments, theoretically, only 1 cell would remain, which the body's own immune system could then kill. There are basically 2 types of chemotherapeutic agents, classified by the way they interfere with cellular reproduction. They are cell cycle specific and cell cycle nonspecific. Cell cycle specific drugs are most effective against rapidly growing tumors, that is, tumors with a large portion of cells in cycle. Drugs that are cell cycle nonspecific don't have their action confined to a specific phase, so they are active in all phases of the cell cycle, regardless of whether or not the cells are cycling. Therefore, they are most effective in large tumors that have fewer actively dividing cells. Chemotherapy drugs work best when given in combination. Always combine drugs which have a high level of individual activity against the tumor, which have different mechanisms of action and different toxicities. Now we will discuss types of chemotherapeutic drugs. The first type of chemotherapy drugs are the alkylating agents. They are cell cycle